In this video, we'll be going over some harder examples for factoring difference of squares expressions. Let's look at our first example. If we look at this expression, we can see that 16x squared y squared can be rewritten as 4xy all squared, and the 9z squared term can be rewritten as 3z all squared. So this means that this expression is now in the form a squared minus b squared, where a equals 4xy and b equals 3z. So we can use the difference of squares formula, a squared minus b squared equals a plus b times a minus b, and rewrite this expression as 4xy plus 3z times 4xy minus 3z. And this is our factored expression. Let's look at this example. This expression cannot be rewritten as a difference of two squares yet, but we'll notice that we can factor out an xy from both terms. So if we factor out an xy from 25x to the fifth y cubed, we're left with a 25x to the fourth y squared. And if we do the same with our second term, minus 16xyz squared, we're left with a 16z squared. So now the expression inside the parentheses, 25x to the fourth y squared minus 16z squared, can be rewritten as a difference of squares. We can rewrite it as 5x squared y all squared minus 4z all squared. And now this is a difference of squares, a squared minus b squared, where a equals 5x squared y and b equals 4z. So this means we can rewrite the expression inside the parentheses as 5x squared y plus 4z times 5x squared y minus 4z, and this is our final answer. Let's look at this slightly more interesting example. We can rewrite x to the fourth minus 1 as x squared all squared minus 1 squared, which is a difference of squares, a squared minus b squared, where a equals x squared and b equals 1. So we can factor this as x squared plus 1 times x squared minus 1. We can actually factor this expression even further, because if we look at the expression in the second parentheses, x squared minus 1, we'll see that it's also a difference of squares expression, which we can factor. X squared minus 1 is equal to x squared minus 1 squared, which can be factored as x plus 1 times x minus 1, and this is our final answer. In certain problems, such as this one, we need to apply the difference of squares formula multiple times to fully factor the expression. Let's look at this example, which is quite an interesting one. If we look at this expression, there doesn't seem like there are any obvious terms in common that can be factored, but we'll see that there's an x squared plus 2xy plus y squared in this expression, which is a perfect square expression. We can rewrite this as x plus y all squared, and the minus z squared remains the same. So this expression is now x plus y all squared minus z squared, which is a difference of squares, a squared minus b squared, where a equals x plus y and b equals z. So we can use the difference of squares formula to rewrite this as parentheses x plus y plus z times parentheses x plus y minus z. And we can simplify this expression as x plus y plus z times x plus y minus z. And this is our final answer. In this example, we had to use the perfect squares formula to rewrite this expression as a difference of squares before we could use the difference of squares formula, and this is a technique to keep in mind when doing harder factoring problems. In this next example, we can see that there are two perfect square expressions. We can rewrite this as parentheses x squared plus 6x plus 9 minus parentheses y squared plus 4y plus 4. And both expressions can be rewritten as perfect squares. So we can rewrite the expression in the first parentheses as x squared plus 2 times 3 times x plus 3 squared. And we can rewrite the expression in the second parentheses as y squared plus 2 times y plus 2 squared. So now using the perfect squares formula, we can rewrite the entire expression as x plus 3 all squared minus y plus 2 all squared. This expression is a difference of squares, a squared minus b squared, where a equals x plus 3 and b equals y plus 2. So we can rewrite the entire expression as parentheses x plus 3 plus parentheses y plus 2 times parentheses x plus 3 minus parentheses y plus 2. We can simplify this expression even further by rewriting it as x plus y plus 5 times x minus y plus 1. And this is our final answer. So let's work on another similar example. Just like in the last example, the first thing to do is to group up the terms as 9x squared plus 12x plus 4 minus parentheses 4y squared minus 12y plus 9. And we'll notice that the expressions in both parentheses can be rewritten as squared terms. So now we'll see that we can rewrite the expression in the first parentheses as 3x all squared plus 2 times 3x times 2 plus 2 squared. And the expression in the second parentheses can be rewritten as 2y all squared minus 2 times 2y times 3 plus 3 squared. So we can use the perfect squares formula to rewrite the first expression as 3x plus 2 all squared minus the second expression, which we can rewrite as 2y minus 3 all squared. So now this expression is in the form of a difference of squares, a squared minus b squared, where a equals 3x plus 2 and b equals 2y minus 3. So we can rewrite this as parentheses 3x plus 2 plus parentheses 2y minus 3 multiplied by parentheses 3x plus 2 minus parentheses 2y minus 3. So now we can simplify this expression further by taking out the inner brackets and rewriting this as 3x plus 2 plus 2y minus 3 multiplied by 3x plus 2 minus 2y plus 3. And we can simplify this further as 3x plus 2y minus 1 times 3x minus 2y plus 5. And this is our final answer. Alright, so this next example is definitely a lot more involved. We can see a 4x plus 1 to the fourth minus a y to the fourth. And the first thing we need to do is rewrite this as 4x plus 1 squared all squared minus y squared squared. This expression is now a difference of squares, a squared minus b squared, where a equals 4x plus 1 all squared, and b equals y squared. So we can use the formula to rewrite this as parentheses 4x plus 1 all squared plus y squared times parentheses 4x plus 1 squared minus y squared. The expression in the first square brackets, 4x plus 1 all squared plus y squared, cannot be factored any further, so we will rewrite it exactly as it is, 4x plus 1 squared plus y squared. But if we look at the expression inside the second square brackets, we can see that 4x plus 1 all squared minus y squared is a difference of squares, a squared minus b squared, where a equals 4x plus 1 and b equals y. So we can factor it as 4x plus 1 plus y times 4x plus 1 minus y. We can simplify this expression by removing the inner brackets. 4x plus 1 all squared in the first square brackets is equal to 16x squared plus 8x plus 1, and the plus y squared term remains the same. In the second square brackets, we can rewrite this as 4x plus y plus 1, and the expression in the third square brackets is equal to 4x minus y plus 1 without inner brackets. And now this expression is simplified as much as possible, and this is our final answer. So here's another similar example, but with more terms. The first thing we'll do is rewrite this as 5x minus 3 squared, all squared, minus 7y minus 2 squared, all squared. So now this expression is in the form a squared minus b squared, where a equals 5x minus 3 all squared, and b equals 7y minus 2 all squared. So we can factor this as 5x minus 3 all squared plus 7y minus 2 all squared multiplied by 5x minus 3 all squared minus 7y minus 2 all squared. The expression inside the first square brackets cannot be factored any further, so we'll rewrite it exactly as it is. The expression inside the second square brackets is in the form a squared minus b squared, where a equals 5x minus 3 and b equals 7y minus 2. So we can factor this further as 5x minus 3 plus 7y minus 2 multiplied by 5x minus 3 minus parentheses 7y minus 2. We can simplify this expression even further. The 5x minus 3 all squared in the first square brackets is equal to 25x squared minus 30x plus 9, and the plus 7y minus 2 all squared is equal to 49y squared minus 28y plus 4. The expression in the second square brackets can be simplified as 5x plus 7y minus 5 if we combine like terms, and the expression in the third square brackets can be simplified as 5x minus 7y minus 1. If we simplify this expression further by combining the like terms in the first square brackets, the expression can be simplified as 25x squared minus 30x plus 49y squared minus 28y plus 13, and the rest of the expression stays the same as follows. And this is our final answer.